Hi, my name's Mark, and this is going to be the 2013-2014 SAT practice test right off the ETS website. We're going to start with section 2, the math. All right, so number 1, the 70,000 is written as 7.0 times 10 to the n. What is the value of n? Now, I notice a lot of my students sometimes go right to this and start plugging in answer choices, and that's going to eat up maybe 15-20 seconds. Maybe that doesn't sound like a lot, but those 15-20 seconds compound throughout an entire SAT. So we want to look at a faster way of doing this, and really the question is asking us how many places do we need to move this decimal to make 7.0 into 70,000. That's going to be 1, 2, 3, and 4. So n equals 4, which is D. All right, let's go on to number 2 here. On a car trip, Sam drove m miles. Kara drove twice as many miles as that. And then Darren drove 20 fewer miles than that. And so that's going to be answer choice B. The SAT, it loves to do this sort of substitution of an equation into another equation kind of thing. And right now it's being tested in a simple way, but later we'll see the same kind of concept recycled as more difficult questions. So we want to have a lot of facility with substituting and modifying equations in an algorithmic fashion like this, like stepwise, step by step. So number 3, x and y are positive integers. If x and y are positive integers, what are all the solutions x, y of this equation? Now, the way I recommend solving this, I want to show you 2 ways. One is the quick way, and one is a slower formal way, which I think is important to know. The first quick way is just to use process of elimination. Whenever I use process of elimination, I like to go ahead and start with answer choice C, and I tend to adjust up and down from there because the answer choices usually are in some kind of ascending order or something similar. So we got a 1 and a 4 and a 2 and a 2 for our answer choices. Now, 1 and 4 plugged in for the x and y. Does that get us 11? Well, 3 plus 8 does indeed equal 11, so this part's good. How about a 2 and a 2? 6 plus 4 equals 10, so that doesn't work. So we can eliminate answer choice C, but we got a valuable bit of information here. 1 and 4 have to be in the answer choice, so we can eliminate B, keep D, and eliminate E automatically because they don't have this ordered pairs or answer choice. So let's look at D. How about this 3 and 1? Does 9 plus 2 equal 11? Yes. And there's our answer right there. And that's how I would hope you would solve the question if you're actually taking this as the test. But I want to show you the more formal way. And the reason why I want to show you the formal way is, again, just like with number 2, sometimes, actually all the time, the SAT test writers will recycle these concepts and turn them into different level of difficulty questions. So if I wanted to solve something like this formally, I would first isolate a variable. So we got 2y equals 11 minus 3x, and then we're going to divide this both sides by 2. And now we have to ask ourselves, what values of x force y into being, as the problem says, a positive integer? And furthermore, x has to be, as a problem given from the problem, a positive integer. So that means we took a samurai sword and we chopped infinity in half, essentially. By the way, the rigorous mathematicians out there might be angry at the expression chop infinity in half. But intuitively, we have chopped infinity in half, and we don't have to mess with any negative values all the way up to 0. None of those will work in this equation. Now, how about 0? 11 minus 0, 3 times 0 is 0, divided by 2 is not an integer. All right, so 0 is out. What about 1? Well, 11 minus 3, we get 8, divided by 2 is 4. That's it. That makes y be an integer. How about 2? 11 minus 6, 5 divided by 2, that's 2.5. Not an integer. 3, though, 11 minus 9 is 2. 2 divided by 2 is 1. That is an integer. And then, after 3, as soon as we get to 4, because it has, remember, x has to be an integer, we got 11 minus something bigger than 11. And now we've dipped into the negatives, and y can't be negative. So 4, all the way up to positive infinity, is right out, and we're left with just 1 and 3. And the only 1 and 3 for values of x. And the only ordered pairs that have 1 and 3 in their x places are the ones associated with D. Okay, so that's the formal, slower way of solving this. that will come more in handy once we see the similar kind of concepts tested at more difficult problems. Okay, so number 4 here. A company's profit P in dollars for producing X machines in one day is given by this formula. P equals 500X minus 20X squared. Okay, and if the company produces 10 machines in one day, then according to this formula, what is the profit for this day? So this is essentially a function problem. And the way, I know functions, when people are very first introduced to them, are kind of confusing. And so I like to tell my students that functions are like a box here. And sometimes you don't even know what's in the box. There's some sort of operation hiding in that box, some machinery that does stuff, okay? And into the box, there's a funnel for inputs that go into the box and into the machinery inside. And X's go into that funnel inside, and then they go into the machinery that's in the box, whatever it is, and then out come f of x's, which are similar to y values. Okay, so we're going to put x's into the box and we're going to get y's out. So that's what's happening here. This, even though the SAT doesn't write it this way, this is essentially saying p of x equals, and then this is what's in the box. This is what's the actual machinery in the box. These are the gears of x's and y's and multiplication and addition and raising variables to powers, all that stuff that's going on in the box. And x is what goes in, and they give us x. The x's are how many machines produced in a day. So x equals 10. So let's put 10 into the box, so p of 10, and let's see what comes out of the box. So 500 times 10 minus 20, 10 squared. All right, so we got 5,000 minus 2,000 here, and that's 3,000. All right, now let's see what we got. It's answer choice C. Okay, so this, I know that for those of you who already know about functions, this might seem like an overly complicated way to explain the problem. But my point is we need to really get a conceptual understanding of functions for when this shows up as a more difficult problem. Okay, so let's see here. I'm looking off of another screen, another computer here to look at the test. So number 5, what is the average or arithmetic mean of the 3 quantities as such? So we add them together and we divide by how many there are. So there's 1, 2, 3 of them. So we'll see right away that these ends oops. I wrote the problem a little bit incorrect. So it's 12 minus n plus 12 plus 12 plus n, and there are 1, 2, 3 terms. We're going to divide by 3, and you'll notice now that the ends cancel out, and there are 1, 2, 3 12s left, and you're dividing by 3, so the answer is just 12, and that's B. Let's look at number 6. Ooh, I better clear the screen for this one. It looks like I'm going to have to draw. We're going to see my masterful artistic skills now, right? So let's draw this big Dorito chip here, and we're going to draw the Dorito chip within the Dorito chip. All right, this is ABC. And this is AMC. So the isosceles triangle, ABC above. So this is isosceles. AM and CM are angle bisectors of BAC. By the way, anytime with angle notation, I notice some students don't know this. Anytime with angle notation, they say angle BAC, they're saying that this is going to be the thing sandwiched within the angle. So this is BA, there's our vertex, C, and it's asking for that angle measure, or it's referring to that angle measure right there. Okay, so that's a little side note. So this is an isosceles triangle, and they're telling us that this is equal to 40 degrees. So we know that all the interior angles of Dorito chips equal 180 degrees. That means there are 140 degrees, because 180 minus 40 is 140, 140 degrees left to apportion between those two angles. So what's 140 divided by 2? It's 70. So this whole thing is 70, and this whole thing is 70. And now we got this fancy pants word, angle bisectors. AM here and CM are both angle bisectors. That's just a fancy way of saying it cuts these angles in half. So this is a 35, and that's a 35. because 70 divided by 2 is 35. So now we have two angles of this interior, smaller Dorito chip. And 35 plus 35 equals 70. And so how many degrees are left over after we take 70 from 180? Well, 110. And they're asking for angle A. Again, M is what's sandwiched inside the notation here. A MC is the filling in between the two pieces of bread here. And so that's the angle they're referring to. And 110 is answer A. All right, let's go on to number 7 here. Fruit salad. Sometimes I think the ETS test writers want to make us hungry while we're taking this test. Okay, so number 7. Fruit salad of pineapples, pears, and peaches is mixed with this ratio, 2 to 3 to 5 respectively by weight. And what fraction of the mixture of the weight is pineapple? And there's our pineapple. So it's 2 over these things added together. So 10, which simplifies to 1 over 5, which is answer choice A. Number 8, in the figure above, square RSTU is inscribed in the circle. And what is the degree measure? What is the degree measure of ST? So here we go. Here, back to some more masterful art. Okay, please pretend that's actually inscribed in the circle. So when something's inscribed in the circle, that means that when a square is inscribed in a circle, that means its 4 corners just perfectly touch that circle right there, and it doesn't go past and it doesn't fall short of touching the circle. And the square has 4 sides, and so this chunk of the circle is going to be, well, 1/4 of the entire circle, because the square has 4 sides, and it's cutting the circumference up into 4 equal chunks right here. 4 equal chunks. Well, how many degree measures are in a circle? We do a 360-degree spin. That means we do a complete circle. For those of you who remember old school video games like Legend of Zelda, Link would do his 360-degree spin. That means a full circle. So what's 1/4 of 360 will give us, what does it ask for? ST. And that is 90 degrees. And so we got answer choice C. Number 9. Notice that the SAT likes to do a little bit of testing of set notation and set logic. So a P and Q are 2 sets of numbers. A set's just a collection of stuff. Right? You could have a set of all the socks in your drawers. All right, and you can ask how many of the socks in your drawers are pink. Maybe you don't have any pink socks, and maybe the answer to that is an empty set. There's nothing in that set. Or maybe there are 4 pink socks in your drawer. Then the answer, then you can designate that as pink sock 1, pink sock 2, 3, and 4. So P and Q are these 2 sets of numbers, whatever they are. We don't know what the numbers are. And it's saying the one condition here is every number in P is also going to be in Q. So if there's a sock in P, same sock is going to be in Q, all right? So let's say socky number 4 here. Sock 4 is in both P and Q. Would that satisfy the condition? Yes, it can, because we're looking for what cannot be true. So A is not the correct answer. B, 5 is in neither P nor Q. Well, if you got a sock labeled 5 and it's not in P and that sock is not in Q, would it satisfy the condition that every sock in P is also in Q? Yes, that doesn't necessarily violate the condition. How about 6? Oh, socky number 6 is in P, but it's not in Q? Does that satisfy the condition that every sock in P has to be in Q? No, it does not. And there's our answer. All right, so let's go on to number 10. For number 10, let me just say, we got this. We're starting talking about rectangular blocks and cubes and all this stuff. There are 2 ways to solve this problem that I like to show. One is first I want to show you, to do the first way is I want to show you a skill that's generally good to have, and that's how to draw a cube. To draw a cube, I like to draw a square like this. I like to draw a square, another square kind of offset from it, and then I just connect the corners. Okay, this kind of helps with a lot of SAT problems. And from here you can now start to draw the 3 by 2 by 1 cubes that could fit into here. That that is one way to do it. Another way is just to think in 2 dimensions and then project it up to a 3-dimensional problem. So if this is a 6 by 6, so we're just looking at this surface here of the cube now. This is 6 by 6. How many 3 by 2 rectangles can fit in there? Well, this way, if this is 3 and this is 2, we can fit 2 of them, because 3 plus 3 is 6. And if this is 2, then we can fit 2 this way. Or sorry, 3 this way. So because 2 plus 2 plus 2 is equal to 6. So now we got these 3 by 2s right there. And how many of them are there? 1, 2, 3, 4, 5, 6. So you can put 6 3 by 2 rectangles into this 6 by 6 square. Now let's project that up into 3 dimensions. All right, let's project it up into 3 dimensions. It's 3 by 2 by 1. How many units of 1 fit in 6? Well, 1, 2, 3, 4, 5, 6. So there are 6 layers of this. So what's 6 times 6? It's 36. And then the answer is D. All right, let's go on to number 11 now. Okay, here's another one where we could solve this with plugging and chugging and making up numbers. But that kind of takes time. Again, it's kind of like number 1. It's going to slow us down, and we might start fiddling with this. So if you're stuck and you just can't think of another way, then plug and chug and, you know, substituting answers in and making up numbers and putting them in can be useful on the SAT. But we also want to know the formal way of doing things. So if a does not equal 0, we got 5 over x equals 5 plus a over x plus a. What is the value of x? Here we have a ripe opportunity for cross multiplication. So 5 multiplied by quantity x plus a equals x multiplied by quantity 5 plus a. Then we have 5x plus 5a equals 5x plus xa. The 5x's will cancel out. And then we have a 5a equals an xa. So now, when is this true? Let's go ahead and divide that out, and ta-da! X equals 5. I had to look down again because I needed to make sure that x could not equal 0. Because if x equals 0, then I'm sorry, if a equals 0, then we can have a problem, okay? And there will be multiple answers all of a sudden. But here we can narrow it down. They told us that a cannot equal 0, so this has to be some non-zero thing. And then we won't run into a divide by 0 problem. Right? We can't run into a divide by 0 problem here, and so x equals 5. And that is answer choice E. Let's go on to number 12 here. Oh goody, more drawing. And I'm not going to attempt to draw all those triangles within a triangle. I noticed that this question has eaten up a lot of time for my students. Sometimes I have students come to this and they start counting triangles and doing a lot of mathematical operations that are slowing them down. And remember, when if you find yourself really doing a lot of computation on the SAT math, you're probably going about it in an overly torturous way. All right, so we got this whole figure is composed of 25 small triangles. So the whole thing, we got a lot of triangles within, and that are congruent and equilateral. So each triangle it takes up the same amount of area. And it says the area of DFH here, DFH is 10. Now, we can count DFH's triangles. There's 1, 2, 3, 4 of them. So 4 triangles gives us an area of 10. And if there are a total of 25 triangles in the whole thing, so 25 triangles, let's go ahead and erase. Oh, that's too soft of an eraser. Let's go ahead and erase this. What will 25 triangles get us? Well, to go from 4 to a 25, you're going to have to multiply by 6 1/4, 6.25. At this point, it's okay to pull out. Now, this is actually justification. If you didn't do that in your head, go 25 divided by 4. Ta-da! We got a 6.25. And so you had to multiply 4 by 6.25 to get this. And so we got to do the same thing over here. Now, let's not just resort to this so soon. 6.25 times 10 is simply move the decimal to 62.5, and ta-da, that's answer choice E. Okay, so don't get too reliant on this guy, because believe it or not, punching numbers into a machine opens yourself up to a lot of error. Look at number 13 here. If the equations above are true, which of the following is the value of y plus z? Now, maybe in your algebra class, your teachers taught you that if you have three unknowns, and here we got an x, y, and z, and only two equations, you can't solve it. It's impossible to solve for two unknown. To solve for an unknown, when you have to solve for three unknowns, and you'll have two equations. To solve for three unknowns, you need three equations. Same thing for four unknowns, you need four equations. 10 unknowns, you need 10 equations. Ooh, that would be a headache-inducing problem. 50 unknowns, 50 equations, right? So whenever the SAT gives you more unknowns than it gives you equations, and I've only seen them do it with two equations, three unknowns, and three equations and four unknowns, if I recall. Whenever you see that kind of situation, you need to find a way to get rid of some of the unknowns entirely so that you narrow down the number of unknowns there are. So instead of doing this the traditional way that you learn in school, which is to start isolating variables and plugging them into other equations, we need to figure out how to get rid of one of the unknowns. And look at this. Immediately I see that both equations contain 3x. And if I subtract this whole second equation from the first equation, that will be completely eliminated. All right, so now that we're subtracting, let's not forget to distribute this negative sign all the way through, even here. I notice a lot of times people will forget to put the negative right there, and then they'll get something else entirely. So the 3x's cancel out. We got a y plus c equals a 5. And ta-da, the problem does ask us for y plus c equals 5, and so the answer is E. All right, so let's go on to number 14 here. Okay, so a boat costs X dollars, and this cost is to be shared equally by a group of people. In terms of X, how many dollars less will each person contribute if there are 4 people in the group instead of 3? All right, so we got an X divided by 3 for each person. That's case 1. Then we got an X divided by 4. That's case 2. And let's just subtract straight across to see what the difference is. So our common denominator can be a 4 here, 3x, and so it's going to be x over 12, which is answer choice A. Number 15, if y equals 2x plus 3 and x is less than 2, which of the following represents all the possible values for y? I just remembered something. I had a student once solve this in a really creative and fun way that I'm going to show you. First, I'll show you the formal way. But I remember we were working side by side through this test, and I think he solved this problem faster than I did with this neat trick that he had. But first, let's go ahead and do this the formal way here. So for the formal way, we're going to do some algebraic manipulation. Let me go ahead and move my notes around here. We're going to do some algebraic manipulation here, and we're going to isolate our x. So 2x equals y minus 3, and then x equals y minus 3 over 2. And now we're going to ask ourselves, if this has to be less than 2, what values of y force it to be less than 2? All right, so in other words, this whole thing has to be less than 2. And this is a little substitution I just made and turned this into an inequality. So let's continue. Y minus 3 is less than 4. Let's re-continue up here. And then y is less than 7. And that's answer choice A. So that solves the problem the formal way. But I want to show you the way the student of mine once solved it very rapidly. So he said, okay, x is less than 2, right? So let me just make sure we're still on the same page. We're on number 15. Y equals 2x plus 3. He said, okay, if x is less than 2, I'm going to plug in a value just barely less than 2 to see what's probably the biggest value of y possible. All right, so I think he pulled out his calculator and he went 2 times, well, what's a small value less than less than 2 that we can plug in. I think he went 1.99999. He put in several nines there. Then he added 3, and he said, well, in this case, y equals 6.999999. And so that's just not quite 7, so y must be less than 7. Then he immediately circled A within like 5 seconds, you know. So I thought that was pretty neat. Okay, number 16. For number 16, I think I want to clear this board because I want to do a sort of general, now that I'm looking at this, I want to do a general review for number 16. So the graphs of the functions f and g in this interval, constrained interval, are shown above, and which of the following could express g in terms of f? So the SAT loves that phrase, express this in terms of something else. In this case, that's sort of just mathematical notation for how do you get this something else to look like this other thing. So how do I get f to look like g? What do I have to do to f to make it look like g? So when I look at that, I can see that they have gone to pains to show me that f of x and g of x are essentially the same curve, just one is shifted up. All right, so f of x is shifted up into g. Otherwise, they have the exact same contours, the exact same highs and lows, and so on and so forth. So let us now review our function transformations. And I think you should just memorize all 8 of these. So if f of x is some original function, let's say it's x squared, it's going to look like, and here we go, time for my not so masterful drawings. X squared looks like this. It just touches the origin. If we make this negative, here's our first transformation. Transformation number 1, I want you to memorize. In other words, a negative x squared. What that does is it flips your function upside down, or if it's already upside down, it flips it right side up. So I notice one mnemonic device my students have employed is they say, well, negative is sad, and it takes a smiley face and makes it a frowny face. That's an okay mnemonic device. It's just be careful, because if it starts off like this and you slap on a negative sign, it will flip this way. So now frown becomes a smile. So mnemonic devices can be risky sometimes. So just keep that in mind. So the other transformation is, once we multiply this by some value greater than 1, and or less than negative 1. And so in other words, 5x squared. What this does is it actually makes the graph, it starts making those y values shoot shoot higher quicker, or shoot lower quicker if it's negative, right? And that essentially has the effect of narrowing our function. If this is x squared, this is going to be rough approximation of 5x squared. So it slims down. But the other transformation is if there's a fraction in here. So in other words, something like half x squared. That's going to make those y values, or the f of x's, go up slower as your x's get further and further away from the origin. And the effect of that is to actually make your graph wider. So it starts to widen out in comparison to our original function here. Okay, now we have, what if we just add a value to our function? What that does to the original function, if this is the original, so in other words, this would be x squared plus 2, for instance, that's going to shift you up 2 units along the y-axis. It's going to look exactly the same, but just be shifted up. And vice versa for minus. Right? This is shifting it down. It's going to look the same, but be shifted. And then let's see, I got 1, 2, 3, 4, 5, and I want to do 2 more, 6, 7. Well, okay, so I called it 8 function transformations. I suppose the 8th would be a negative of the negative, but so 7/8 common function transformations I want you to know. The other is if you add something inside to the actual x rather than to the overall f of x, or the overall function. So in other words, it would look something like this. When you do that, that's going to shift your original function along the x-axis to the left. If you're adding, see, this, some people get confused. If you're adding, you're not going up the x-axis. You're not going to the right. You're going to the left. All right. If you make yourself an xy table, you can prove that to yourself. And same if, so this would be 3 units to the left, and this would be 3 units to the right because we're subtracting now. Okay. So just go ahead and write down these 8 steps here and just memorize them. It's going to really, it'll serve you well for the SAT. And it makes number 16, which, let's see, the ETS rated this 4 out of 5 in difficulty. It's going to make this 4 out of 5 in difficulty problem really quite easy if you already have that memorized, because right when you look at those functions, you see that g of x is just simply f of x shifted up 1, and the answer is b. Turns it into like a 3-second question, essentially. Let's move on to number 17. Now we take note, by the way, we're on the last 4 questions of the section. In the beginning of the section, in general, the SAT will order its questions from easiest to sort of the medium difficulty questions up to the hardest questions. No, that's not a very strict order, by the way, so sometimes you'll get a little bit of mixing in, but in general, it's a progression in difficulty. So once you get towards the end, things that might seem like a super obvious solution are often not, the right answer. So number 17 is, I would consider this unusual for an SAT question because they tend not to test these particular concepts in this particular way, and there are numerous ways of solving this guy. So we got an x and a y. We got this shape, some number of sided shape. We don't know what. Covered by a piece of paper, right? This happens in real life all the time. You have to figure out this guy. No, I'm just kidding. So they want to know how many sides this covered polygon has if x plus y here equals 80. Okay? So the first thing to remember, and this is from the sort of math primer in the blue book, first thing to remember is that the interior angles of any regular polygon add up to 180 multiplied by quantity n minus 2, where n is the number of sides in the polygon. And what do you know? We got a polygon staring at us right now. And it's 4-sided. So if we plug in a 4 there, we're going to get 180 multiplied by 2, which equals to 360. All right, so 300. The angles, all the angles in here add up to 360. You have an A and a B, and all the angles are equal. So A and B are equal. We know that x plus y is equal to 80. So 360 minus 80 will give us what? 280 degrees left over in this shape. And so A and B equally share that 280 degree measure. So they're both equal to 140. Next thing we know is that all the angles, for every angle you add on to a shape, you're adding on a side, okay? So in other words, with a triangle, we have 3 sides. That means we have 3 angles. The square, we have 4 sides. We got 1, 2, 3, 4 angles, and so on and so on. It's like an octagon has 8 sides and 8 angles. So that lets us know that 140 multiplied by the number of angles in the entire shape has to equal, ta-da, this thing. All right, it has to equal 180 n minus 2, because that's going to be the number, the measure of all the interior degrees, angles also. So now, n, we got to solve for n. That's the number of sides that this thing has. So n equals 180 over 140. It simplifies to 18 over 14. That's what, 9 over 7? And this is multiplied by n minus 2. And let's get rid of this before it confuses me. So n equals 9/7 n minus 2. So let's go ahead and simplify that some more. 9/7 n minus 18 over 7. And then let's collect like terms here. So we can turn n into 7n over 7. 7 over 7 is 1. 1 times n is still n. Minus 9/7 n, blah, 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 9/7 in equals a negative 18 over 7. So this is equal to negative 2/7 in, which is equal to negative 18 over 7. That's good that the negative signs will cancel out, because it'd be really strange if I discovered that there are a negative number of sides to this shape. Whoa, we're in a sci-fi novel now, way outside the realm of the SAT, right? So those negative signs cancel each other out. And then let's multiply both sides by 7 over 2. 7's go away, and n equals 18 divided by 2, which is 9. So n equals 9. That's kind of an odd number. It has an odd number of shapes, this thing. And let's see, 9 is answer choice B. So there are other ways of solving this problem. Let's see, I wrote them out over here. Oh yes, there are 3 or 4 different ways you can go about this. One is to start looking for patterns in the 180 in -2 and start plugging in the number of sides, and you see the patterns go up, and you know that the pattern has to be divisible by 140 and be divisible by it and make an integer. And so if you went that way, then you would see that all the sides, if you're just plugging in with your calculator, all the sides would have to equal to, let's see, I got a 1260, and then pull this out. 1260 divided by 140 would give us a nice integer. Otherwise, if it were less than that, you got a 1080 divided by 140. That would give me a 7.71, and I know the polygon can't have 7.71 sides. Okay, so it has to actually be an enclosed polygon. Number of sides has to be an integer. Okay, so that's one way. If you get stuck, you can use your calculator to look for a pattern. Okay, but let's not belabor this point too much. Let's go ahead and finish up. Okay, number 18. One thing to know is that on the SAT, number lines are drawn to scale. Right? I know a lot of times it says figure not drawn to scale, but I don't think I've ever seen that for a number line. I'm pretty confident that all the number lines on any SAT are completely to scale, so you can trust that the tick marks are spaced out evenly. So I was starting to think of exceptions, and then I realized I wrote a math test once where I did a really mean thing where I spaced the number line out in a really haphazard way to confuse people. But we're not doing that. We're not doing that here. So one of the important skills for the SAT is to be able to estimate. So we see that S is in between a -2 and a -3. It looks like they put it smack dab in the middle. So S is a -2.5. T is a little bit closer to 0 than the -1. So I think we should go ahead and estimate it to be about -quarter. Let's keep everything in a decimal. U looks like in between 0 and 1, but closer to 1. So let's say 0.75 or 3/4. And then at last V. And that looks smack dab in between the 2 and the 3 here. So let's go ahead and assign it 2.5. Okay, now let's start plugging and chugging and just do a process of elimination. And again, I like to start with the answer choice C whenever I'm doing a plug and chug. So the absolute value of S minus T. So S is a -2.5. And we're going to subtract -quarter. So S is 2.5. So this is going to be roughly like a 2 1/4, so like 2.25. I know we're estimating, but so if our values end up being really, really close, then this could be a problem, but we'll see that estimating is okay. So let's see if there's anything bigger than 2.25. S minus V over here. Let's see, S absolute value, -2.5 minus 2. Oh, this is pretty promising here. We got an absolute value of -5, which is a 5. So C is straight out. And then for E, let's see, S plus U, all in absolute value. So our S is a -2.5, and our U is a 0.75, which actually makes this value smaller than 5. because we're getting closer to the origin with this. So we can automatically knock out E, and then A and B. You can tell by looking at it, negative 2.5 plus negative 0.25. That's still not going to be bigger than 5. And then B is an S plus V, and negative 2.5 plus, oh, it's 0. We're smack dab at the origin. So remember, absolute value is essentially measure of distance from the origin. That's how I like to think of it, and it helps me. I like conceptualizing it that way. It's how far away have we gone from the origin. So anyways, the answer is D now. I don't like it. I notice some students implicitly conceptualize absolute value as take off the negative sign. And that's not a good way to conceptualize it, because if you do, and you get to this kind of problem, you might get confused, and you might accidentally start knocking negative signs off of these values before you actually do the arithmetic manipulations to them. So that's why I like to think of it as how far away are you from home base there? How far have you traveled from home, where home is 0? Okay? So I notice I personify numbers a lot. So number 19 here. Don't forget to wear your glasses when you go take the SAT. Otherwise, when you're starting to count tick marks, you might miscount them. Once I think it was I forgot my contacts and my glasses, and I was sitting there counting these tick marks, looking close, putting my nose to the page practically. So on the day of a rainstorm, the depth of the water at a certain location along the winding river was recorded hourly, and the results are indicated in the line graph above. Now you notice, by the way, in that line graph, they have a little squiggle there along an axis. That squiggle means you have no idea how much distance is between the origin and, say, that first tick mark, okay? The squiggle could be a 1, it could be a 2, it could be a 50. Though 50 would be pretty extreme, right? That'd be like a truly torrential flood of rain. But anyways, each unit on the vertical axis represents 1 foot. If the depth of the water decreased 10% from 3 to 4 p.m. All right, so let's look at 3 to 4 p.m. What was the depth of the water at 4 p.m. itself? So when we look at 3 p.m. and we look at 4 p.m., we see that there's a unit of 2 drops. So a 2-unit drop is 2 feet, right? So 2 feet. And they're telling us that this is a 10% drop. Well, what do you know? That means 10%, this 10% decrease is the key to unlocking this problem. Because now to get 100% of the water level at 3 p.m., because it's a 10% decrease of what? Think about it that way. It's a 10% decrease of the water level at time 3 p.m. So if we want to find a 100% of the water level at 3 p.m., you just got to multiply by 10, right? So multiply by 10. Over here we got 20 feet. Is the depth of the water at 3 p.m. Those ETS test writers sure are sneaky, because answer choice D is 20. So if you're in too much of a hurry, you might just circle D and move on and get the question wrong, even though you understood it. So don't forget to, sometimes I like to tell my students to actually underline the part of the question with a question mark, to remind themselves to look at that and really make sure that you're answering the actual question, because it says, what was the depth of the water at 4 p.m.? And we've just discovered 3 p.m. here. To get from 3 p.m. to 4 p.m., well, as the graph shows us, we drop 2 feet to 18 feet, and that is answer choice C. I notice, the SAT, especially towards the end, they are especially good at making intuitively obvious wrong answers. Okay, so just be careful with that. So let's, I got the phrase intuitively obvious wrong answers from a test prep guru named Jen Dziura. She writes in the Huffington Post and elsewhere. She really has amazing advice on SAT and GMAT and just test standardized testing in general. So if you want to get in touch with her or look at the materials that she has online, you will be well rewarded. So let's go to number 20 here. For all numbers a and b, I'm going to call this a donut b, be defined by a donut b equals ab plus a plus b. For all numbers x, y, and z, which of the following must be true? So you notice I showed you quick ways to solve a lot of the problems. And part of the reason is once you get to a problem like this, it does require, it eats up a little bit, it eats up more time than we would perhaps like, right? So we now hopefully have extra time left over. And in fact, if you really want to shoot for a really high score, I recommend trying to finish each section with, something like half to 3/4 of the allotted time. That goes for math, the writing, and the verbal. Though I know the last section of writing is a real sprint, but still try to finish within, get yourself to where once you get really comfortable with all the concepts and conceptually you're ready for the SAT, you know all the material backwards and forwards, then I recommend working on timing so that you have time to double check, because it is almost inevitable that you'll make at least some tiny error, like accidentally dropped a negative sign, or you made a bubbling error, you forgot to flip an inequality or something like that. So even if you know how to do every single problem, you still might make some mistake like that, and you want to go back and double check. I remember once, to my horror, I had made quite a few bubbling errors on by getting things off by one, and I was able to, luckily I had plenty of time, right? I think it was on a critical reading section, so I was able to fix everything. But still not advisable. And by the way, for fixing, I like these Ticonderoga pencils. Ticonderoga writes really well as a number 2 pencil, and the eraser seems to work especially well. So of all the pencils that I've used for standardized tests, I recommend the Ticonderoga. Let's go ahead and actually do this problem now, the donuts. So whenever I have conditions, these Roman numeral condition problems, I like to go ahead and break them down one by one. Okay, so x donut y is equal to y donut x. All right, and then it's told me that this is, let's see, xy plus x plus y, and that equals yx plus y plus x. Are these things really equal? Well, the x's cancel out. If you subtract both sides by x, the y's cancel out. And xy and yx are the same. Okay, so yay! Answer choice 1 is correct. Now let's do a little bit of process elimination, before we move on here. If we know 1 is correct, that means B has to be wrong. C has to be wrong because it says 2 only and 3 only. And so we're left with answer choices A, D, and E. We already have eliminated 2 answer choices. If you get stuck right here, you should at least guess, because if you can eliminate at least 1 answer choice with 100% confidence, then it's in your best interest to guess, all right, statistically speaking. So let's go ahead and look at condition 2 here, Roman numeral 2. So x minus 1 quantity donut with x plus 1. I'm going to make myself hungry talking about donuts. You know what? When I'm done with this video, I'm going out for donuts. All right? I think there's a Dunkin' Donuts near me, in fact. So first we got to multiply these two things. So, by the way, whenever you got a variable plus or minus some constant, and then you're multiplying it by the same variable, but opposite the sign, so minus the plus, the same constant, then you know you only have to multiply the n terms together. All right, so x squared minus 1. And then it's saying plus x minus 1 plus x plus 1 to complete the definition. So let's go ahead and collect our like terms here. X squared, let's see, plus 2x, and this cancels out, so then minus 1. So that's what that simplifies to. And now let's go ahead and do this. X donut x. So that's going to be an x squared plus an x, so plus 2x minus 1. And what do you know? These two do, in fact, equal one another. So yay. So now we can cancel out A. And what does D say? 1 and 2 only. So D might be the answer, and E might be the answer. So let's check our final condition here. X donut y plus C equals You know, one thing I'm starting to think now while I'm doing this, and it's the kind of thing I want you to be aware of once you're taking the actual test. One thing I'm realizing is this is kind of a lot of computation, right? This is starting to take up time. So I should start looking for just keep my mind open for a shortcut. And indeed, look at this. X donut Y we have already done, okay? And we see that it is, oh, I scratched it out, great. But still, we see that it's XY plus X plus Y. So we don't even have to think about that. And X donut Z is the same thing, but we're going to replace the Y's with C's. So plus XZ plus X plus C. So okay, I'm at least now done with this half of the equation. So let's go ahead and go over here. So X, Y plus C plus X plus Y plus C. And then let's go ahead and multiply the X through. XC plus X plus Y plus C. And now that we're setting them equal to one another, let's start subtracting one term off from each side, one by one. So I subtract xy from both sides, those cancel out. I subtract this x from both sides, they cancel out. Ditto for the y, and ditto for the xc. But now we are left with z equals x plus c. And it says for all numbers x, y, z, which of the following must be true. Those are critical terms, because if I say, hey, x might be 0, then yeah, sure. If it said what could be true, that's one thing, but what must be true for all numbers. And that does not work for all numbers, right? So 3 is straight out, and that cancels us out, and we're left with answer choice D, okay? So that finishes up section 2, and hopefully you move swiftly through this section, and you can go back now and double check if this was the actual real thing on game day. And I recommend that over what you do is, as you're working through these practice tests and you're working through all the tests in the blue book, is that you actually buy yourself 3 journals that look like this, these kind of journals. Buy 3 of them, and label one SAT Math, another one SAT Reading, and another one SAT Writing. And as you're working through these tests, if you ever guess on a question, like if I got to number 20 here and I got stuck, but I eliminated some answer choices and I was down to D and E and I guessed D, I want to label this thing a G to show that I guessed on it. So even if I get it right, that means I still didn't 100% understand what was going on. Still not quite comfortable. Everything that you guess on and everything that you get wrong, I recommend you record it in your journal. Okay, and then as you work through your tests, what's going to happen is you'll find patterns to the kind of errors you make. And then, for instance, maybe every time you add 9 plus 5, for some reason you get that wrong, or you get stuck on functions, or you stall on remainder questions. Anytime you get to those things, you'll be able to find those patterns by looking in your journal, and then you can really direct your practice to address those areas. All right. So maybe do something like 5 blue book tests. You'll find a pattern, address those patterns really strenuously, really try to correct those things, and then you can do the other 5 in the blue book test and see what kind of impact you make, okay? So if you like this video, go ahead and let me know. If there's interest, I'll keep doing more of these videos. I'll do all the other sections on this, and I can do all the tests if there's sustained interest, okay? So I think now it's time for me to go and get those donuts, all right? So have a good day. Thank you for watching.